Hi everyone, welcome back in day 3. So today we are going in the deep into the RAG system in the vector and embedding. Let's break down what is an embedding is in AI and why it's so important. So an embedding is a way AI convert the complex data like a words, images, audio into the numbers called the vectors. Think of it like a mapping thing in into a math space and similar items closer looks together like this one. So for example, in language embedding help AI to understand the cat and kitten are related because the vectors live near to each other. So how is useful? So let's go more into deep in the embedding. So embedding let AI amazing things like a search smarter, recommended product, summarize text, audio, even recognize the images. They are also initial for an AI. So this RAD RAG, retrieval augmented generation. RAG is uses the embedding to search and retrieve the most important relevant pieces of the information from the massive database. So basically, embedding is an let's suppose we have the semantic spaces. Okay, someone is putting the some text like dog and wolf. So dog and wolf, how much is similar together? So embedding will be work here. That we are dividing into the vector, and we will see what is the relevance related to the both in the both one. For measuring the similarity, so mathematical metrics like cos and similarity and calculate the angle between the vectors to determine the relevance. And the vectors are working in the nearby space like in this example I showed. Next is indexing. So indexing is a phase is one time process to prepare the external data for the efficient semantic retrieval. So first step is load. So whenever the client will be, they will be upload the document like I want to from I'm working in the organization. I want from my database. My agent will be go and they will be give the information from the my database only. So we are uploading some data in the document loader. Then the split will become and they will be split that PDF into the small chunks. After that, embedding will be work. Embedding will be convert each text chunks into the numerical vectors, and then that save the vectors and text into specialized database that is called the vector store. So after that, whenever the user will be give any prompt basis on the vectors, my agent, my rack system will be work. So this is a flow how the vector database will be help in the rack system. So this is one of the rack example. So let's suppose user inquiry for the what is a special about Kimi. So this is related to the Kimi K2. So this is a source knowledge and the augmented prompt is using the context below. I'll take the example for the embedding. So I'm importing some library that will be help us to create this session for the embedding. So first importing the sentence transform. Then so now I'm importing the pip install sentence transformers and the second learn for this. And why importing this library? Because the sentence transformer import the library that pre-trained models that convert the sentence into the dense vectors. So for that one, next simply I'm using this library. So I'm writing here from. So now I imported the sentence transformer and the Gaussian similarity for the vector space. So my model is imported successfully. Now I need to create some documents. So I will be create documents and I will be write some text here. Let's suppose if I'm writing. So I write it this text, so the capital of the France and some random text I write it here. Now I need to run this, so I run it now. Next step is I need to import the my document is here. Now I'm creating one new column, document embedding. So because I want to do the embedding in this text, so embeddings equal to model dot encode, and now my documents I will be call my documents, so that documents will be converted into that one. Okay, now I need to run this. Now I'm going to the next line. Here I will be import. Let me add some more rows here. So okay, now my document model in code that will be running. Next is user query. So we need to user will be asked something. Let's suppose user query is what is capital of France. Yes, because that is related to the that one. So I run this query. Okay, now next what is the we will put that query into the user to the query importing embedding. So query is also we need to do embedding. Okay, so that will be check the what is the weightage of the what is capital of France, so that will be convert into the numerical, and numerical will be check into the documents, like how these vectors will be work. Then after that user query we put it the in embedding. Now let's go for the user query. So now user query is done, query embedding is done. Sorry, now we need to go to the similarity one. So how we need to check the similarity? Scores with the quotient similarity, and we are doing the document embedding. So that will be work. After that that will be check the scores, and then we need to extract the best one, which best index, let's suppose which one they fit. So we are calling the numpy for the argument max, and they will be check the similarity scores. So that similarity scores will become into the numbers. So let's print this first. I'm printing the similarity score. So what is the similarity score? So print the user query and best embedding. So the user query is what is capital France, and the best matching document is showing that the capital of France is Paris from here. So it's showing that the number. I need to extract the what is a similarity score also. So let's print the similarity score. So what is showing here? The print. Then we need to write similarity score, and similarity score is here. So let's see, it's showing the similarity score is like 0.87, 0.10, and this one. So this is the best one, is showing that 0.87 the similarity score for the vector. And what is the similarity score for the retrieved the context? So that we need to find. So let's write here print. Now we need to find out the into the document. So retrieved. So I'm writing to print here first, retrieved score. So what is the retrieve score? We need to check it. So I'm writing into the curly bracket the documents, that will be check in the documents. Then in the documents we need to check the best. So it's showing that retrieved context is the this one. And what is a confidence level we need to check? So confidence score we can check with this. So this is my retrieved context, and this is my vectors that is stored. So this is how we can calculate the vector, and we can do the embedding. Understand how it's in work in the background. How the embedding let AI do amazing things like a search smarter, recommended products, and summarizing the things. So this is our this is all about for vectors and embedding. Thank you guys. So this is all for the vectors and embedding. So thank you guys.